huge part of that. Every single completely learn the technologies better, though, as soon as you start writing code against them. It's going to be substantially better than just knowing where to click in the web console. Okay, I'm going to bounce back and forth, by the way, in this class. I'm going to show you the CLI, and I'm going to show you the web console, but I'm not going to write any code. We're not going to do any Python work or anything like that in here. Not in this course. I do write some code, but in this course, we're not going to do that. And for the exam, you don't need that. Okay, it'll help you. Yes. Is it required? No. All right. Another question that just came in as well, does the exam require us to know YAML for infrastructure as code, is what that stands for. No, you're not going to write any YAML. I guess let me put it that way. You're not going to write any YAML, but you should probably be able to look at YAML and know what it's doing, or at least know what's being defined. Very, very high level. YAML is not a difficult thing to learn. I would suggest you know your basics around JSON and YAML both. Namely because everything uses it today, and not even just the cloud. I mean, the whole cloud, you're going to use YAML and JSON a lot. And I'm not even just narrowing it down to Google. I mean, the whole cloud, Amazon, Google, Azure, everybody's using YAML and JSON. Plus most of your third-party applications and most APIs are going to use JSON or YAML as well. And so to not know it puts you at a huge disadvantage in this industry. Okay, I would say forget any programming languages. If you don't know YAML or JSON syntax, that's square one. But here's the thing. You can learn it in an afternoon. I mean, YAML and JSON syntax is not a hard thing to learn. Now, that's just the syntax. Putting it into place in something much larger, again, writing that stuff, that would be more focused on very specific programming kind of exams and stuff that are out there. You're probably not going to have to write anything at all on any of these exams. Especially, definitely not this one, but to be able to read it, that's going to be important, at least to be able to see what's going on, right? Do you know what an array looks like in JSON? Do you know what an array looks like in YAML? By the way, it's super simple. An array in YAML is just a hyphen and a value and another hyphen and another value and a hyphen and another value. You got indentations and stuff going on. It's quite easy. Okay, just take the time to learn it. But yeah, great question, SG. Take the time to learn those things if you don't know them yet. Okay, wouldn't be but a couple of days at most. Like I said, in the afternoon, you could probably learn the syntax of YAML, and then JSON might be a little bit longer because it's got more symbols. YAML is going to deal with indentation. Okay, let me see another question. What's the score to pass the exam? Well. To pass the exam, there isn't a fixed score. Google does not publish a fixed score for it. Most people estimate it's about 80% passing rate, but again, I don't think it matters. Why does it matter to you? At the end of the day, when you're done, you get a pass or fail. All you can do is say, "I'm going to do my best." I don't know why people ask this question, to be honest. And I'm not picking on the person that asked it. It's more about difficulty, right? You could have an 80% where you have to get 80% of the questions right, which means it's very small amount can be wrong. But what if it's a super easy test, right? Meanwhile, you could have a 60% pass rate, and somebody's like, "Wow, great! I only need to pass 60%, a little bit more than half of the questions, and I pass." But what if those questions are extremely difficult? Forget about the score that you need to pass. Okay, it's a weighted, and there's an algorithm behind it. It's not an easy thing to calculate. It's not something you're going to be able to calculate on your own, anyways. Just go in, answer as many questions as you can correct, and be done. Okay, forget about passing scores. Forget about passing rates. That's not going to help you in passing these exams. By the way, a little bit of background on the exams as well. I've got every single AWS certification, and I've got about half the Google ones. I'm hopefully by the end of the year, I'm going to have all of the Google ones knocked out. I just haven't made the time to do it. But when I schedule it, I just schedule it. I study for a day or two, and I take the exam. Because I use this stuff, it actually makes it a lot easier to pass the exams. I'm not saying they're easy. Some people will struggle a lot on these exams. Because I use this stuff day in and day out, most of the exams are actually pretty straightforward for somebody that uses it all the time. Okay. Another question that came rolling in from PP. What do we do with the SDKs, for example, Python SDK? I'll explain what those are for and how they work. They are not needed for the exam, though. Okay, so you need to understand what the package contains or what it would be used for, but that's for automation. So you write some Python code that's going to ultimately issue the API calls on your behalf using the SDK. Okay, all right, and if you're not a programmer and none of that matters, none of that really makes sense to you, that's fine too. We can come full circle on that a little later. All right, moving on. So first off, before we really, actually, let me back up one just for a second here. What I'm going to do is kind of level set the class here. I get a lot of people that come to this class that have never touched GCP, okay? Maybe not even touched the cloud at all. They're completely brand new here. So I'm going to give you kind of an introduction here. Now, if you're somebody who's been working with this stuff for a long time, you may learn some new things here. Even though it's the basics, you might actually learn some new things. So stay focused, and I think you'll be happy. All right. All right. So again, I hear this phrase, the cloud is just somebody else's data center. Now, you could not be farther from the truth. Absolutely, that is not anywhere close to what's going on here. Somebody else's data center is a co-location facility where you can just go rack your hardware. And even if you went virtual hosting providers, right? Companies like Rackspace, were pre-cloud. Okay, meaning you could go get a virtual machine out in the public internet and pay somebody a monthly fee for that virtual machine and call it a day. Okay, the cloud came on the scene and changed the world for this. Virtual machines and somebody else's data center, that's not what we're dealing with. In fact, I would argue the strength of the cloud is going away from virtual machines. Most of my customers that are really mature in this landscape, that have been working with cloud for quite some time, are doing everything they can to get off of virtual machines. They want to use services. And that's what it's all about. It's about services at the end of the day. In fact, only about 10% of the offered services are actually network, in a more traditional means, network related, meaning they have classic IP addresses. You have to put them in a subnet. You have to design a network around them. 90% of the services are actually just purely API based, meaning you just make a call to the service and you get an answer back. Okay, I'll show you some examples of this as we move on. This particular certification is not a programming certification. It is going to be more focused on the infrastructure. But the big picture of the cloud is we're actually working away from infrastructure. The thing is, we have to understand, most people, when they're first getting involved with the cloud, or most companies, when they're first getting involved, they're going to start with what they know, and they're going to know infrastructure already. So that's the natural bridge into the cloud, is infrastructure. But then once you're there, you start realizing, wow, there's better ways to do this. Okay, let me give you just a brief example. Let's say I want to make like a queuing service. Okay, In GCP, we have a product called PubSub, okay? It's one API call to create a topic in PubSub. Not a hard thing to do. It's one command at the CLI. It's one call with some code. Very easy to do. If I were to build that same thing out using an infrastructure, I would have to first build a network. I would have to build routing tables and subnets and all that stuff. I would have to build out a virtual machine, at least one, but I probably want some resiliency. So then I got to build resiliency into it. I got to harden those virtual machines. So I got to go through all kinds of security protocols, process, right, to harden that whole thing. Then I got to install some queuing software. Then I got to make sure that the firewalls allow the proper ports for that queuing software from the particular sources they need to be accessed from. And then again, making sure test my failover, test all the fault tolerance and everything else. It literally is one command, or it's a week of work, at least, okay? The cloud, even with the cloud, because in the cloud I can do all of that stuff, but realistically in an enterprise I probably have to get it all approved. I have to get networks built. Again, I got to install software. I got to do all that, and then someone probably got to approve it all. And then if I've got data to migrate, if I'm doing some sort of migration or something, then I even got a lot more going on. Ironically enough, a lot of people are afraid of lock-in. A lot of people come to the cloud and they go, oh, I'm not going to use cloud technologies, like specifically like cloud services, because I don't want to be locked in, right? I'm sure some of you are thinking like that, or you've heard this concept of, oh, I don't want to use a cloud offering because then I'm locked into that service. Did you know that actually has the least lock-in? The stuff that has the most lock-in is custom networks. So custom networks, you go build your own custom networks. Now you got to do all that work I just mentioned. If I wanted to move that queuing solution from Google to on-prem or from Google to AWS as an example, again, one command over in AWS. I could start pointing to it. I could migrate in 20 minutes. Okay, it's just some quick calls in my app, and I'm good to change my queuing services over to AWS or something. If I wanted to migrate that entire queuing service over to AWS, it would be a lot more work than 1 or 2 commands. Okay, ironically enough, private custom networks are actually the most complicated, carry with them the most security points of interest. Best way to put that, maybe. I'm not going to say it's insecure, but it has the potential to be far more insecure than a classic cloud service as well, because now you got to worry about every single service, every single software, every single thing installed on that server with a service. I don't have to worry about any of that. So it is not just a modern colocation facility. It is not just somebody else's data center. It's about services. So now I've got this service that just, boom, I got a queuing service available with 1 command. Oh, by the way, maybe you want some other service, facial recognition software. Well, instead of installing all that software and doing everything I just discussed, we have a product in Google called Cloud Vision. And again, just a couple of commands, I'm ready to go on doing facial recognition or image recognition or data classification of my data, or I want to do text to OCR kind of recognition. Those are products that are just ready to go right now, and they're just a call. They're just a command. That's it. I just issue a command from my laptop. I issue a command from a server. I issue a command from within GCP. It doesn't matter where I am to issue that command either. Okay. So no, it is not just somebody else's data center. Okay. And now you have this map here. I believe this map is actually slightly outdated. I got to update the slide here with the latest map. The point of it is just to kind of show you a geographical kind of understanding of this stuff too. You've got a multi-billion-dollar network here that you get to use for free. And here's what I mean by free. The network is already built. Google's already put all the money into it. Google has the best network in the world. Okay, better than any telecommunications provider, better than anybody else. Google has the best network that exists on the planet. And we're using it for this stuff that we're building, okay? So what's going to happen is you're not going to have to buy circuits. You don't have to buy routers and switches and fiber optic cables and network circuits. What's going to happen is you use the resources. And the resource billing is how you indirectly pay for the network, okay? There's going to be resource consumption that's going to take place. At times, you may have to pay for data to move across that network. So in other words, let's say I transfer 1 gig of data from US Central 1, which is Iowa, and we copy it over, I don't know, to Mumbai. When I copy that data across, I may pay to copy 1 gig of data, okay? I'm not going to pay for bandwidth. I'm not going to pay for circuits that are persistent. I'm just going to pay to use it, perhaps. Okay, and again, that's going to mean I have much less waste. I'm going to pay much less in the grand scheme than going out and paying for a huge network of our own. Okay, so these blue dots represent regions around the world, and a region consists of a collection of zones. A zone is a collection of data centers. And so think about it this way. I've got a collection of data centers that could be across the street from each other. Right? They could be right across the street from each other, but I have a collection of data centers. Maybe there's 10, maybe there's 20. But they could be very close. They could be slightly spread out, but they're probably in the same metropolis area, as an example, maybe fairly close for low latency. But then there's a fault zone that's created around that cluster of data centers. Then Google builds another cluster of data centers and does the same thing. And those 2 clusters of data centers are kept separate from each other. Then they have their own power, they have their own internal networks, and then they are connected to each other in the terms of networks. But if one zone fails, it's designed and architected in such a way where that failure does not propagate to the other zone. And then those 2 zones make up a region. Okay, those 2 zones make up a region. So in that regard, a region will consist of at least 2 zones. The magic number is 3, though. Okay, some zones are more. Some regions even have more than 3. 3 is what Google's goal is for all of their regions. So you have 2 to 3 clusters of data centers that you get to work with, and you don't have the data center individual view, which is a good thing. It's abstracted. We just select the zones we want to work in. We select, we build out our networks, we build out whatever we want to build out. But we get to use these technologies for our benefit, right? And again, they're already built for us. There's already massive, all the HVAC, all of power, everything is all taken care of, and we don't pay any of that. And that's what a lot of people mistakenly do some bad math here. They compare, like, let's say a virtual machine in GCP to a virtual machine on-prem, and they try and compare costs. Or they say, well, on-premises, here's what that hardware would cost equivalence. That's really faulty math, because in the cloud, it's not just the virtual machine. You're paying for the entire network. You're paying for the racks. You're paying for the air conditioning and the dehumidifiers. You're paying for the security guards. You're paying for all of it, right? And then you try and compare that virtual machine to hardware on premises. Your math is not anywhere close to the same, all right? Not anywhere close. So let's talk a little bit about some some terms. My apologies. So public cloud versus private cloud. So you've probably heard these terms. A lot of people hear public cloud and they think that everything is public because it's in the cloud and it's public. This is completely false. So a public cloud is confusing. People hear that word public and it scares them. All public cloud means is, think of it as a public utility. Okay, think of it like that in those terms. It means that the public at large is able to use it. It means that you can create an account on it and start using it. A private cloud just simply means you own it. You own the hardware. You own everything about it. At the end of the day, a private cloud is nothing more than your own data center that you've got cloud technologies installed into. Okay, so private cloud just means it's your physical data center. You own the hardware. And by the way, owning the hardware is the problem. That's a big part of the problem. Public clouds are for the public to use, but you don't have to worry about the hardware, right? And that's a huge benefit. Let me give you just a brief example of owning the hardware and why it's a problem. I do jobs all the time, by the way. I'll talk in terms of thousands of systems, even for small businesses, small to mid-sized businesses that are doing a job. Let's say this job normally would take you a week on one system. Why wait a week? What if it normally takes you 12 hours on one system? Well, here's the thing. 12 hours on one system or 1 hour on 12 systems is the exact same cost, okay? Because it's about collection or aggregate cost of resource consumption. It's not about how many systems you run, okay? And so it's time. Time is the factor there. So if I run, again, one system for 12 hours, 12 systems for 1 hour, it's the same price. So there are jobs that I can run thousands and thousands of systems on, and it's still cheaper or the same or cheaper than maybe running one or two monster systems, okay? So the number of systems, do you think you could go and at the moment just run a command to initiate, let's say, 2,000 servers in your current data centers if you have a data center? If that's the kind of model you're coming from, do you think you could run a single command and launch 2,000 systems right now without talking to anybody, without asking about it? Just do it, get a job done, and have them go away. Okay, it's not possible. I have not seen a single data center that is set up this way. It's not going to happen in the enterprise, and so this changes the way we do things substantially. Right? You are not limited by hardware anymore. You have virtually unlimited hardware. Okay. So I got a question from KP, and it's a really good question. So, like, what are the top 2 or 3 key strengths of GCP that a customer would like to go with adopting GCP rather than AWS? So, first, I'm going to preface that question with the comparison of cloud providers. I will compare cloud providers throughout the class, and there's a reason for it. A lot of people come to this class or come to various classes of mine that are coming here to check out GCP, but maybe they've got their knowledge in AWS or they got their knowledge in Azure, okay? That's great. So the comparison helps that learning curve for those people that are already very familiar with, let's say, AWS, and they just want a kind of a quick crash course on GCP. They need that comparison to help kind of identify maybe what the differences are and things like that. So real quick note on that one. I don't want to leave the Azure people out of the discussions, but I'm not going to try and compare to every single cloud provider, okay? I think that muddies the waters quite a bit. So I will do some comparisons to AWS, namely just because AWS is the biggest, most common cloud provider. Okay, so the likelihood of a customer having AWS workloads is higher than on GCP or Azure. Okay, so if they're here, the likelihood of some of you having AWS knowledge is high. So that's the one I'm going to compare with most of the time. Okay, I was putting that out there that if I do comparisons, it's with AWS. If you are coming from Azure or OCI or something else, and you have that knowledge in those other areas, just know when I make comparisons, it's just to illustrate the point of similarities or differences. You'll have to identify those, but I'm going to give you some resources that Google actually publishes to compare with Azure as well. Okay, I don't think Google publishes anything for any other cloud providers, but they actually show specifically comparisons for Azure and AWS. I'll give you those resources. Okay, now as far as the top 2 or 3 key strengths of GCP, oh my word. Okay, so a couple of things. Google actually is the oldest cloud provider. Okay, a lot of people think it's AWS. AWS is the oldest public cloud provider, but Google's been doing cloud longer than anybody. They actually are better at it than AWS. They're just having to shift things. So they're still kind of in that process. It's different when you get big corporate customers. The reason I say they're older is Google was implementing cloud technologies and cloud methodologies in the late 90s, long before AWS was around. In fact, most of what AWS is doing are built on Google principles. Okay, when it actually talks about like architectural principles, AWS built off of many Google principles. All right, so Google does this really, really well. But Google did not have that customer-facing public perspective when they built their cloud. So they've been evolving on that over the last couple of years. It's really been standing out. So here's the thing. They have faster launch times on just about everything. So launching a VM, as an example, is typically faster in GCP than AWS. Their resources are just more efficient in general, I found. Things scale a little bit cleaner and all of that. Machine learning and intelligence kind of stuff, Google, I mean, that's what Google does, okay? I mean, just as a whole. Amazon's kind of, I'm going to say, somewhat distracted, okay? I'm not going to say they do a bad job. Amazon's amazing at what they do, but Amazon.com is a revenue producer, a large one, for their business, as is AWS. Google, it's all kind of the same, right? Everything Google does, I mean, they're big on analytics, right? So do you think that GCP is big on analytics? Of course it is. So I would say analytics and machine learning, nobody beats Google, okay? Analytics and machine learning, Google is the best. Now here's the thing. Your data has to live there. So some people say, well, I want to use AWS for some things and GCP for some things and Azure for some things. That whole idea of multi-cloud is very tricky because at the end of the day, it is going to come down to where is your data. You can't have your data sitting in AWS and use GCP to analyze it, at least not effectively, because the data transfer charges will probably make you go broke. Okay, you will probably spend way more money than you should doing that. But analytics, I mean, nobody beats Google. Okay, now are there other holes? I think AWS probably has a more well-rounded cloud offering, meaning there are kind of some of those little nuances that that kind of fill in the gaps that Google, I think, is still filling in. Okay, Amazon's kind of gotten to that point where, like, now they're like, what do we make, right? They're kind of at that point. Google's not quite there. There's still maybe some little spots that they have yet to fill in, plug certain holes. But overall, Google is faster. It's more efficient. Most of the time, their scaling of their system, scaling of their data, just overall tends to be the best. I mean, when it comes to data, Google is a data company. I mean, that's more so than Amazon, right? But anyways, yeah, we can move on. So anyways, understand the difference between public clouds and private clouds. So again, just because it's the word public in there doesn't mean your stuff is public. Doesn't mean your resources and your data is somehow public. So here's the thing. The cloud is actually more secure than anything on premises, assuming you do a couple of simple best practices. First off, they follow... Yeah, so MM has a good point there. They do have the core cloud offering. That is where I think Google is still falling short a little bit, but they are stepping on the gas. They are doing a big effort here. They actually changed basically the driver or the head of GCP's offering and just Google in general a couple years ago, and now their focus on corporate enterprise has been substantially bigger. In just the last year or two, they've really stood out. So things are moving in the right direction for Google here. But just because the corporate offering for AWS is well, it doesn't mean that the corporate offering for Google is poor. But technologically speaking, Google is superior in many ways. It's just that working with business, the administrative side or exactly what the enterprise wants from them, they're still adjusting some things there. Okay, so your stuff is not public. Now, I mentioned that the cloud can be more secure than even on premises. It is actually out of the box. It's what we call zero trust, meaning there is zero access to anything. Google does not trust you, but they also don't trust themselves, and that's a really good behavior pattern. And by the way, this same behavior pattern is in AWS, and that is zero trust. The idea is some resource or product in GCP cannot talk to your resources or products. Okay, so multiple products can't just talk to each other, even if they carry the GCP name. Okay, there's no access at all. Any resource you build out, you are in full control over what has access to it. Okay, Google employees do not have console access to anything. They don't have access to any of the data. The data is fully managed automatically, and these automatic systems are provisioned by you. Okay, and that's the important thing to understand, is when it's zero trust, there's zero access, and then you provision the access. And Google can't do that for you. You have to do it. And so let's say product A talking to your data, you have to actually allow that access because by default it's completely blocked. There is zero access. On premises, there is not zero trust. Okay, and by the way, we'll talk about zero trust a little bit more coming up, but there is no zero trust on prem. Here's why. If you build out a network on premises, and let's say you have a switch, and everybody were to plug into that switch, let's just take Wi-Fi out of it to not complicate things as much. Let's just say we were hard-coded, hardwired into that switch. By default, we would all be able to talk to each other. Our systems could all communicate. The only way to lock that down is to add a firewall. And when you add a firewall, now you filter. So the idea is it's wide open until you lock it down on premises. Okay. In the cloud, it's completely locked down, and then you open up what you need to open up. Okay. Very different approach. So it's zero trust. Principle of least access is the next thing. Principle of least access is only allow what you need and nothing more. So again, instead of worrying about the philosophies or concepts of locking something down, you focus on what do I need to open. And if I just need to open up this one API call, then that's all I'm going to open up. If all I need to do is open up one particular port number, that's all I'm going to open up. I'm not going to open everything. So it's not about locking things down. It's about opening up. Okay. And so, no, nothing is accessible over the internet unless you explicitly build it out to be so. Okay. And then, again, being shared and public, is it easier to compromise something in the cloud? So some people have this misconception or misnotion that one little slip up in the public cloud, suddenly all my stuff is public. Well, guess what? One little slip up on a firewall on premises, and suddenly everything is public. I used to manage firewalls in an on-premises world. It is not hard to make a bad rule. Okay, so of course you have to have good process in place, good education in place, have the right people in place. But if somebody made a bad rule on a firewall, they could do exactly the same thing. Okay, that's no different. I would actually argue it's harder to make stuff public in the cloud because you actually have to build it out. You have to architect it. You have to plug in the internet. You have to, virtually, if you will, you have to plug in the internet. You have to run various commands to open up the necessary security. It's not usually just one command. You have to run various commands to actually open up whatever you need to open up. Whereas you could argue you're logged into a firewall, I can potentially add one firewall rule, just one, that completely destroys our security, right? So it's actually more well regulated in the cloud in that sense. To have to jump through a bunch of hoops, to have to jump through a bunch of steps to do things poorly. Okay, but you can do things poorly in the cloud just like you can anywhere else. The difference there, I think, is enterprises have a very bad habit of hiring people and putting people in place that have no business managing this. That's the difference. If you have somebody managing your rules, have somebody managing your firewall rules, have somebody managing your IAM policies and things that doesn't know what they're doing, they will break your environment and you might end up in the news because of it. Okay, so that's the issue. I wouldn't go hire a firewall administrator on premises that doesn't know what they're doing and hasn't proven it just the same. Okay. So you've heard of these terms, SaaS, PaaS, and IaaS. So SaaS is software as a service. PaaS is platform as a service. And then you have infrastructure as a service. The software as a service would be like your actual full-blown software, right? So Salesforce is a product a lot of enterprises use. Salesforce is a software as a service offering, but so is like Gmail. Okay, Gmail is a software as a service. It's an email service, right? It's an email application as a service. So is Facebook or any of these. These are all like those are technically all SaaS offerings. Okay, there's no software to install. You use it as a service, right? PaaS is usually something more you're going to like build on top of. So maybe it's a component or something to a larger build, typically speaking. So I can build out usage. So I gave you an example of a queuing service like PubSub in GCP. That's a PaaS offering because it's going to be a component in a larger thing. I'm not going to just build a piece of software strictly off of a queuing service. Okay. And then infrastructure as a service would be like your virtual networks and virtual machines. Even virtual databases and stuff fall underneath that category. If they have an IP address in the traditional sense, if you have to put this stuff into a subnet and you need routing rules and firewall rules, you're talking infrastructure, okay? But here's the thing. These terms are terrible, okay? So what I mean by that is there are a lot of services today that do not fall into just one of these categories. There are a lot of services that are all three of these. There are a lot of services that are two of these. Here's the problem. I think too many people have gotten hung up on these terms, and I've actually, no joke, I've actually seen employees fight over whether something is a SaaS or a PaaS offering. And maybe they're both right because it depends on the perspective. There's products that we can work with in the cloud that act as a platform. So as an example, image recognition or image recognition software could be argued as a SaaS offering because there may even be a web interface for it that people could go in and use. Meanwhile, it's also a PaaS because I can integrate it into my applications and issue API calls to it and get results back using it as a platform. So it's both. So if somebody argues that it's SaaS, they're right. If somebody argues that it's PaaS, they're right. So who's right? Well, they're both right. And they're both wrong if they're both saying it's exclusively that, right? So let's stop using these terms, okay? Even Google, occasionally I'll see these terms pop up in some documentation somewhere, but Google tries to avoid these terms as well. These terms are not good. Amazon, same thing. You won't find these terms in Amazon. I think Azure uses them a bit more throughout, but I'm a fan of saying there is no point of these. You're not going to have an exam ask you about the definitions of these things. So don't get distracted by these. We're saying just ignore the terms, understand what they are when somebody uses them, but leave it at that, okay? You don't need to try and say something is categorized or put something in a particular grouping, okay? That's not really going to help anybody. There's no benefit to these terms. In fact, in today's world, I would argue these are legacy. I would argue these terms were when the cloud was first emerging. These terms came out. And then now, because there's a lot of overlap, and like I said, some of them are all three, there's everything as a service, right? I mean, at the end of the day, you could say you've got offerings that are mobile applications as a service. There's insert thing here, machine learning as a service, Docker as a service. I mean, there's so many concepts that could just be, thrown that out there, okay? So, yeah, they are thrown out there, but you're never going to be quizzed on these terms, okay? So, I want to point out, I have never seen a Google exam that asked me what these terms meant and what they were for. They might be thrown in there. I can't tell you the last time I've actually seen these terms on a Google exam, okay? Or as or an AWS exam for that matter. Now, yeah, so firewall as a service, as an example, is fine. You can say that. The point is these three that I'm calling out. So let me clarify on that one, Something as a service, everybody does that. That's fine. Just don't argue with somebody. These are different. Firewall as a service is talking about a product offering as a service. That's fine. But if you try and say firewall as a service is a SaaS offering, okay, that's all I'm talking about. So firewall, what some people would do is they would call that a SaaS offering or a PaaS offering. Well, it's both. So firewall as a service is a more specific thing. These three is what I'm referring to. Don't worry about these three. We don't need to classify it. Firewall as a service might actually fall into all three of these, by the way. Not just even two. It might actually be all three, depending on the product itself. So that's fine to call something a service, right? Yeah. Okay, so this exam is all about implementing. So just to highlight, if you are here for the exam purposes, it's about implementing. So there's another certification I also have a crash course on. I mentioned it, the GCP Professional Cloud Architect crash course that I put on. That certification is about designing and planning. And I actually sometimes get some feedback. People say, I wanted it to be more technical. It's not meant to be technical. We can't go too technical on that exam because there are architects that have never touched the keyboard. Okay? And what I mean by that, like command lines or written code. There are architects that are quite good at what they do that have never actually implemented. Google does not require that of you. And so you can be really, really good at architecting or designing without having the hands-on. Will you be a better architect if you have the hands-on, though? I would absolutely agree. You probably would be. Okay, having both is huge. But I just point that out. Okay. Yes. So I have all of the AWS certifications. There's 11 or 12 today. I get it mixed up because they've decommissioned a couple. They've brought some new ones out. I have all of them, and then I have about half of the GCP certifications, as I mentioned. I don't want to get too distracted. Which one's the hardest? It depends on your background. What's hard for me may be easy for you, and vice versa. Okay, so I don't want to get too wrapped up into that. It's not too critical. But here's the deal: the certification tracks and this class and this certification is about implementation. Now, it's not going to have you implement, but it's going to talk about implementing concepts. It's going to talk about things like managing that infrastructure. It's going to get into technologies involved in management of the infrastructure. So management of the infrastructure as opposed to designing it, right? Let's put it into a different perspective. Imagine somebody building a building, okay? Do you think the architect of that building is really good with power tools? I don't know. It's not necessary for that job, right? Could they be good with power tools? Sure, they could be. Do you think they might even approach design a little bit differently if they have it in their mind of how things are going to be actually built? Like, in other words, oh, I've been on the construction side. I know that this is a good architectural design, but it's going to be very challenging to actually build. Maybe we can make it more effective on the build side and still have the best of both worlds, right? If they've actually got that background, they might actually be better, okay? So, yeah, managing is definitely different from designing, 100%, yeah. So, two different certifications, right, for two different purposes. So if you attended that class with me, that's intentionally not nearly as technical because that's not what it's about, okay? That's not what that certification is for. This one is about actually implementation and management. Very, very different. Okay, so these are two different certifications I'm calling out here. Now, I usually recommend, you've probably heard this one from me before if you've taken one of my other classes, I actually recommend you go after both of these certifications at once. And here's the reason why. Can you architect without the hands-on? Yes. Will you be a better architect with the hands-on? Absolutely, a resounding yes. Will you be better at management of it if you understand the design side of it? 100% yes. These complement each other very, very well. These two certifications specifically. If you study for both of them simultaneous, not one and then the next, if you study for them simultaneously and go take both certifications back to back, you will pass both of them much higher likelihood than passing each one individually. Okay, I would highly, highly recommend this of you. If maybe pile that on to you, but I would recommend you go after both of these and study simultaneously. Maybe even take both on the same day, or take one day and the other one maybe a day or two or a couple days later. Okay, all right. So big differences on understanding the two different certifications. Okay. So the basic exam, again, I'm not going to go too heavy on the exam details in here. Once I kind of get past some of this stuff, we're going to go into the technical stuff. We're going to start diving deep. But ultimately, the exam is a 2-hour exam. It's $125 US. It is multiple choice and multiple select. The difference is here. Multiple choice, I've got A, B, C, D as an example. Choose one of those 4 answers. Okay. Multiple select, maybe there's like A, B, C, D, E, 5 possible answers, and they say choose 2. Now, it will tell you how many to choose, okay? It's not just going to leave it open-ended. So if they expect 2 answers, they're going to ask you for 2. But here's the thing. Multiple select is really hard because it's actually more than one question in one. There is no partial credit. So partial credit, if I get one of the 2 correct, the whole question is wrong because I only got one of the 2. I didn't get them both right. So it's either both right or none right. So multiple select is limited in the sense there's only a small percentage of the questions are actually multiple select. They actually have rules around how many they can actually have on a single exam. It's something like 5 or 10%. Okay, I don't know the exact number, but it's somewhere in that vicinity. Multiple select is rare, but you will come across those. Okay, multiple choice is the rest of the exam. Again, multiple choice does not mean it's easy, and they're not going to have you type anything. It is not an active exam. You're not going to go into a console and type commands and do things that way. It's about answering questions, okay? So understand this when you're studying as well. But it doesn't mean you have to memorize. That's the thing. Answering questions doesn't mean you have to have memorization done here. So you ask a mechanic. Let me just give you an example here. So a mechanic that works on a car and has no knowledge of airplane mechanics could pick up airplane mechanics much easier than a non-mechanic, right? Because they've already understand mechanical principles. Okay, there may be little nuances they need to learn, but the principles hold true, okay? Simple example, but a simple bolt and nut, as long as it's, standard threading, you're going to turn right, right. Somebody's heard these terms, righty-tighty, lefty-loosey, but the idea is that, you're going to have that basic concept. The most simple example there, my point is every mechanic knows automatically how to tighten a nut. Okay, you don't have to teach them that every time. So it's not about memorization. In fact, now they can take that tightening of the bolt or nut and apply it to situations that require it, right? And that's what we want to focus on is understanding the principles and the basic concepts so that we can apply them and understand what's going on, not just somebody tells me, oh, on that engine and that bolt makes you turn right and make sure that this is exactly how you're going to take it off, right? That's never in any manuals like that. That's not, unless it's an exception. If it's an exception, it would be defined, but only exceptions, right? Otherwise, they expect the mechanic is going to understand mechanical principles, okay? It's the same thing here. There are principles you must understand. If you understand those principles, passing the exam is substantially easier than memorizing very specific scenarios, okay? Now, this particular exam is designed or geared towards less experience, okay? Doesn't mean it's easy, all right? In fact, I've known people that have taken the professional cloud architect, which is a more expensive exam and is longer, and they expect about 2 years experience. People go, oh, this one will be easy, and they go take this one, and then they fail it because they think they can just take it without any studying. This one is not, I don't want to make it sound like it's easy. It is geared towards people with a little less hands-on experience. Now, if you don't have 6 months experience, doesn't mean you can't take the exam. It's all about how much time and energy you spend on this. Somebody with 6 months experience may only have, I don't know, let's just easy numbers here for sake of discussion. Let's say they've got 40 hours of total experience in those 6 months. Or you got somebody that literally spent all week 40 hours. You got the same amount of experience. It's just faster time, right? So the months time here doesn't really matter. It's about how much effort you've put into your study, okay, and how much hands-on. And hands-on does not have to be production hands-on. It can be just experimentation, lab time, okay. And that's what I want to expose you to in this course. All right. So there are no prereqs. You can just take it. You don't have to take something else to take this one. There's no requirements. You can just go take the exam. All right. As far as how many questions, I always get this one mixed up. There's different certifications. It's either 55 or 65. I'm wanting to say it's 65 questions. I believe it's 65 questions, but don't quote me on that one. You can look it up. Google used to publish this, but I don't know if they publish the numbers anymore. But it's somewhere in there, okay? Yeah, so basic idea, it's either 55 or 65. At the end of the day, like VL mentioned here, focus on like a question every 2 minutes. Yeah, that's just a good time management. Here's the problem with that idea, though, is I'm going to give you a different trick. One of the problems with that is not all the questions are equally complicated, right? So you're going to have questions that are really, really hard and take 5 or 6 minutes, and others that might take you 30 seconds. So it's tricky because what if those really hard ones just happen to be in the tail half of the class or something, tail half of the exam? I'm going to give you a different strategy. So real quick note on taking the exam. For anybody that's taking it here, I would say you do this. Go through the entire exam in the first half an hour. Okay? So you have 2 hours, right? What I mean by that is answer every single question that you know the answer to quickly. All right? You can flag the questions you don't want to answer right now or don't know right now. You can flag them for follow-up. Okay? So this is a testing strategy I do. I'm going to tell you what works for me. Everybody's different. Just take this for what it's worth. But I go through the entire exam in about a half an hour. And so I find all the easy answers. Okay? This does a couple of things for me. I get an idea of what questions are coming also, right? But I can flag those for follow-up. So what I do is I kind of say, if I can answer it in 30 seconds or less, go and get it done. And then when I'm done, I go back and start answering those that I flagged for follow-up. And my second pass, I answer the ones that are maybe a minute. Like maybe I knew I could answer them, but it would just take a little bit of work to do it. Like I know already that it's probably a fairly quick question, but it's not going to take me 10 minutes, okay? Then at the very end of all of this, now you've left the biggest, hardest questions for the very, very end. Here's the thing. That big, heavy question may not be worth any more than the easy one. It all depends on their weighting and their algorithms and stuff. Some questions are not even scored, okay? And you don't know which ones, okay? You don't know which ones are scored and which ones aren't. What if you spent 10 minutes on an exam question that wasn't even scored and then missed out on 5 or 6 questions at the end because of that one you spent all that time on? It's not worth the sacrifice on one question to potentially give up 5 or 6 later because you run out of time, okay? All right. Yeah, those are beta questions, but you don't know which questions are beta. That's the problem. So if you spent a lot of time on one question and just so happened that one question was beta, that would really hurt, right? And you don't know, and you won't even know after the fact. It's a numbers game, exactly. So this is just a strategy that I tell everybody to do. Go through multiple passes on the exam, okay? At the end of the day, it is a numbers game on pass rate, okay? So so make sure that you answer as many. You don't want any questions going unscored. It will not penalize you for an answered wrong question is the same as a blank question. A blank question is still wrong, okay? So you don't want any to go unanswered, but you also don't want to get to the end of this time and have 10 questions left and you're out of time and you're just going you know. That's not going to work for your advantage. Okay. Quick note on timing for this. Sorry, not timing for the exam, timing for the course here. We're going to do breaks about every hour and 15 minutes is my goal. Okay. We're going to do about a 10-minute break, and then we'll go another hour and 15 or so, another 10-minute break, and then that takes us out to the end of the course. Okay. 4 hours, if you kind of just do the math, those are kind of like 1/3 and 1/3 kind of a thing. Okay. Just a little heads up. So we'll do a break in about 10 minutes approximately. Okay. All right. Another question that came in. Okay. So CH asked a question about Anthos. So in my other course, I talk about Anthos being in the exam. I don't think there's very much Anthos at all on this one. Okay. This is about implementation, and Anthos is not like a core implementation understanding. In fact, this one's probably going to be more infrastructure-based, like classic infrastructure inside of GCP. Anthos is actually engineered or designed really for even like cross-cloud and on-premises and things like that. It does have some uses inside of GCP, but no, that's beyond the scope of this course for the most part. Understanding some basic principles about Anthos certainly won't hurt you in case they decide to slip a question in there. But Anthos is not a core thing like it is on the. It's a very could be a large focus on the professional cloud architect certification. Okay, yeah, great question there. All right. So again, pace yourself, run through all the easiest, shortest questions first, flag them for follow-up, come back, and as you answer those that have been flagged, you have to unflag them. Okay, so you have to basically mark it as having been answered now. So just keep that in mind. And so I just start unflagging each question that I answer, and then I basically am aiming towards getting them all unflagged. Okay. Again, no partial credit for multiple answer questions. And you cannot take notes. Okay, you have to do this stuff in your head. This one's a tricky piece, tricky element to this exam. You can't take notes. They won't give you scratch paper if you're doing it in person, and if you're doing it online, online proctored, which means you're taking the exam at home with somebody that basically is watching you and detecting for people in the room or anything that you could be potentially cheating with. And so one of the things is they don't allow paper or pens anywhere within reach. You can't have anything on your desk. Your desk has to be completely clear if you take it virtually. Of course, the testing center is already set up to be that. But if you're taking it at home, you got to make sure you have a completely isolated room with no technology around you other than your laptop and a completely clear desk. Okay, not even a single pen sitting on the desk. I had a test I was taking. The pen, so I have a fairly large desk here. It's, I think, like 7 feet long. And I had a pen at the far end of it. And when you first take the exam, they have you scan the room with the web camera. So you move the camera all around the room, and they take pictures all along the way as well. And then as you're taking the exam, they're reviewing that video and pictures of the room. And I had an exam proctor jump into my exam, I don't know, 10 minutes in or so, and asked me what that was at the end of my table. And I told them it was a pen, and they made me get rid of it. And it wasn't even within reach. Like, I had to lean way over to get to it. But that's kind of how strict they can be. And they need to be. You need them to be strict. You want them to be strict. By the way, you also want these tests to be hard. If they're easy, and it's also easy to cheat, it completely devalues the certification and makes it worthless, right? So we all should want these certifications to be hard. We should also want them to be very strict on the testing criteria, and they are to all of that stuff. And I encourage them to continue to be like that, right? Otherwise, their certifications mean nothing. All right. Okay. So, again, some questions may not be scored. I mentioned that one. Okay, we talked about that already. Some exam resources. These are in the download, the PDF you can download of the slides. So these links are in there for you. There's an exam guide I'm linking to. I'm going to show you this stuff firsthand, but just keep in mind they are in the slides for your reference. But we're going to actually go and browse. I'm going to show you in the documentation, in GCP's documentation, where to find a lot of this information and give you some links while we're going a little later on. This is just reference slide. Okay. Also, when you do create your own personal GCP account, you get a free $300 credit. So not only are there free tier services, meaning they're free to use, but if there's anything you want to use that is not free or exceeds the free tier, you can use this $300. This $300 is valid for 3 months, and then it goes away. So you use it or lose it. This allows you to explore and experiment, but also in that first exploration period, if there's any mistakes that you do make that maybe result in billing you didn't expect, hopefully this will cover that, right? But I'm gonna give you ways to protect yourself, so that's not even ever a concern, okay? But when you create a brand new account, this is automatic, all right? And then again, a list of Quick Labs quests. Quick Labs is GCP's official lab provider. Google owns Quick Labs. If you've done anything for AWS, you may also know Amazon uses this too. There's a little history there. Quick Labs was an independent third party that Amazon used for their labs. Google bought them and started using them for Google Labs too. Okay, so this is Google's official lab provider. Fantastic labs in here. I've called out a few